Hello everyone. Today we will discuss a few problems related with shear force diagram and bending moment diagram. Let us discuss the first problem. Here I have a beam simply supported at two ends. The length of the beam is 6 meter and it carries one point load at a distance of 1 meter from one end. The point load is 5 kilonewton and there is another point load from the other end, and that is also at a distance of 1 meter only, and this point load is of 10 kilonewton, and then I have a uniformly distributed load between them, and the value of this uniformly distributed load is 2 kilonewton per meter. Okay, now this is our first problem, and we have to find out shear force and bending moment. Okay, so what I will do, I will first name the critical positions. Like here I will name at A, let us name this point as B, here this point as C, this point as D. Okay, so your first step is calculate the support reaction. Okay, now how I will calculate the support reaction? For that I will take moment about any point. Now this system is in equilibrium. This system is in equilibrium. That means if I find the moment at point A, so summation of moment at point A, it will be 0. Okay, sum of all moments about point A is going to be 0. Otherwise, if it is not 0, then what will happen, that it will keep on rotating. But as it is not rotating, moment at point A is 0. Now this implies that your anti-clockwise moment is equals to clockwise moment. Okay, what I am saying, your sum of moment is 0, I can say like that, or I can say that your anti-clockwise moment is equals to clockwise moment, because anti-clockwise is positive, clockwise is negative. So either I will write both of them on one side with plus and minus sign, or I will equate anti-clockwise with clockwise. So here my anti-clockwise moment will be here at point B, let us say reaction is RB. So it is RB times 6, this is anti-clockwise moment, this is going to be equal to clockwise moment, that is 5 times 1 plus 10 times, now from point A, this 10 kilonewton load is at a distance of 5. This in between length is what, 4 meter. So 10 times 5 and plus I have UDL of 2. So the total UDL value, the total load, this is 2 kilonewton per meter. So as it is 2 kilonewton per meter, so I will say that this is 2 into total length is 4, and its resultant will act at its center. So at a distance of 2 meter from point C, that means at a distance of 2 plus 1, 3 meter from point A. Okay, so therefore I will find RB. Now this RB is equals to, here the calculation is 5 times 1 5, I will use calculator. Okay, so it is 5 times 1 5 plus 10 times 5 is 50 plus 2 times 4 8, 8 3 the 24. So here 5 times 1 plus 10 times 5 is 50 plus here 24. Okay, so the total will be 79. So 79 divided by 6. Okay, so 79 divided by 6 will give me something 13.166. So this is 13.166. So I can say that 13.167. Okay, this is RB. Now I can find out RA in the similar manner, or I can use summation of Fy A0. So sum of all forces in y direction is 0. So therefore I have RA plus RB. This is reaction going in upward direction, force in upward direction. This will be balanced by downward forces, that is 5 plus 2 times 4 plus 10. Okay, so that will give me the value of RA. So value of RA is what? It is 5 plus 8, 5 plus 8 plus 10. So 5 plus 8 plus 10, it is 23. 23 minus, we will subtract 13.167. So I will get 9.833. So this is 9.833. Okay, we can if permitted, we can round it off up to 2 decimal place. So here it will be 13.17, I will say, and here I will say that 9.83. Okay, so now the next step is that I will draw the shear force diagram. Now shear force diagram, okay, if you wanted to write, you can write the steps, or simply like at point A the shear force is 9.83. So I will go up 9.83. Consider this value is 9.83. Okay, now here I assume that you have already done your shear force and bending moment diagram, so here I am not explaining in much detail. Okay, otherwise, like wherever there is a point reaction, we generally see towards its left and right what are the forces, right? So for point A there is nothing towards left, but on right, if I just move towards right of this, I will get this 9.833. Now for drawing shear force diagram, okay, if on the left of the section, wherever I cut the section, if on left, okay, from the section, if there is any force going up, that we will take positive, and on the right, if anything is going down, that we will take as negative. Okay, so if I cut section anywhere, on the left it is going up, so it is positive, so this positive value will continue till point C. Now at point C, okay, if I cut a section, okay, on the right side of C and C towards left, so this phi is going down, so it will go down. So 9.83 minus 5, this value is going to be 4.83. So 4.83, so not that much down, it will be somewhere like this. Okay, this value is what? 4.83. This value is I will write here 4.83. Okay, not enough space to write, so separately we can do that. Now at point D, or I can start from right, or here see, from left to right, as I am moving now, I will see whatever is going down, I will accordingly make my this S.F.D down. So 2 times 4, 8. Now from this I have to go down by 8. So 4.83 minus 8. So 4.83, if I do 4.83 minus 8, I will get 3.17. So at point D there will be a negative value 3.17. So this will go like this, and here I will get 3.17. Now from 3.17 again we have to go down. This point is what? 3.17. I have to go down by 10 units, so it will become 13 point, it will become 13.17. Then I will go straight, and then here it is 13.17 reaction at B, so I will go up. Okay, so this side plus and this side minus, this is my S.F.D. Now this point where it is crossing this axis is very important for me. So A, B, C, D, I will name this point as E. Why this is important? Because the point where you get the minimum shear force, okay, zero shear force, their bending moment is maximum. So this point is important for me. Now how I will calculate that, at what distance this point is? So for that, criteria of similar triangle will help me out. So you can see two triangles. One is with height 4.83. Now let us assume that this distance is x. Total distance is what? Total distance is 4. So from here to here, the distance is going to be 4 minus x. Okay. Now I use the similarity criteria, and by that I have 4.83 divided by this x will be equal to this 3.17 divided by 4 minus x. Okay. Now I will cross multiply. So 4.83 times 4 minus x will be equal to 3.17 times x. We open the bracket, so we will get 4.83 times 4, 4.83. So 4.83 times 4 will be 19.32. 19.32 minus this is 4.83x will be equal to 3.17x. Okay, this minus 4.83x will go on right. So I have 19.32 is equals to, so it will be 4 plus 4 8, it will be 8 times x. Okay, so therefore the value of x is 19.32 divided by 8. So 19.32 divided by 8, 19.32 divided by 8 will give me 2.415. So 2.415 is this length x. Okay, so the value of x we will keep in our mind. Okay, this is calculations related with S.F.D. Okay, now we will do calculations related with B.M.D. Okay, I will write critical values here, like 13 point here. The reaction here is what? 9.83. Here the reaction is 13.17. Obviously the unit is kilonewton. Okay, now I will rub all these values so that I can perform my bending moment calculation. Now this value x 2.415, x is that I will write here. The value of x we got 2.415. Okay, fine. Now we will do bending moment calculation. So bending moment at point A as well as moment at point B are going to be 0. They are simply supported, there is no moment. Now moment at point C, it is equals to the reaction we have, support reaction we have 9.83. So to calculate the moment, either I will look on the left side or right side for the values, and yes, your sagging moment is positive and hogging moment is negative. So when I look towards left, I find that there is a force of 9.83. Okay, and the distance from point C is 1 meter. So the moment generated at point C is 9.83 times 1, which is 9.83 only. So 9.83, the unit will be kilonewton meter. Okay, kilonewton. No, n should be capital N, because n symbolize Newton. So kilonewton meter, and this k should be small k. Okay. So bending moment at A we know, bending moment at B we know, bending moment at C we know. Similarly, if moment at D we want to calculate, it is easy for me to see on the right side. So on the right side it is 13.17 times 1. Again this is your sagging bending moment, so positive bending moment. And finally we will calculate bending moment at point E, because at point E we have we have zero shear force, so bending moment is going to be maximum here. Now I will see towards left, so what I will get? I will get 9.83. This is sagging bending moment, 9.83 multiplied by, now total distance from point E is 1 plus x, so it will be 3.415. Okay, 3.415 minus 5 times, now the distance x is what, 2.415. Now this is hogging moment, and minus, I have 2 times the distance 2.415, and I have to take the middle of that. I will take this much force and this much force and middle of that. So I can write 2 times 2.415 square divided by 2. This formula I can use directly. Means what I am doing, I am writing 2 into 2.415, which is total load, okay, on the left of point E, that UDL load, and half of that distance, that is x by 2, means 2.415 divided by 2. So this is how we can write, and this will give me moment at point E. Now that moment is going to be the maximum moment. So let us see whether we get the maximum value. So 9.83 multiplied by 3.415 minus 5 times 2.415 minus, now this 2 and 2 we will cancel, so minus 2.415 square, so minus 2.415 into 2.415 I will say, and the result. So result here we get 15.66. What we get? 15.66 kilonewton meter. So you can see that this 15.66 is the highest value. So now I will draw the bending moment diagram. So bending moment diagram, here we will draw the bending moment diagram. Now at point A our moment is 0. At point C, the moment is 9.83. So at point C, here the moment is 9.83. Now I will draw a straight line. Then at point E we have 15.6. So point E is somewhere here, and its value, so here it will go something like this parabola, because UDL is there. So this is 15.66. That parabola will continue till point D, where the moment is 13.17. So 13.17 is something like this. So it will continue, and here we will get 13.17, and then I will join with this point. Okay, so this is your bending moment diagram, positive bending moment I will get. Okay, so shear force diagram and bending moment diagram, right? Now we will discuss our next question. So our next question is a cantilever. No, I will discuss UDL first. So again, one uniformly distributed load is there. First simply supported beam is there. One support at this end. Total length is 5 meter and up to 2 meter. Now here I have UDL. This is for up to 2 meter. The value of this UDL is 3 kilonewton per meter. Then at this end only I have a load of 4 kilonewton, and then from the other end I have a UDL, but this UDL is for 1 meter only, and its value is 1 kilonewton per meter, and again I have a point load here which is 2 kilonewton. So 1 meter from here, 2 meter from here, 2 plus 1 3, so remaining is 2 meter only. Okay, so remaining distance is 2 meter. The total length between these two supports is of 5 meter. Okay, right. Now again, first I will mark these points as A, B, C and D, critical points, and then first I will find moment about point A. So summation of moment at point A will be 0. So this will give me RB times 5. Anti-clockwise moment is equals to clockwise moment. So RB times 5 is equals to 3 times. Now 2 square divided by 2, right? WL square divided by 2, you know, moment by UDL we calculate by this formula, or you can understand this like 3 into 2 will give me total force, and it will act at its center, that means 2 divided by 2, so it is 3 into 2 square divided by 2. This is clockwise moment plus 4 times 2, okay, clockwise plus I have 2 time. Now total distance of this 2 Newton from point A is what, 2 plus 2 4, 4 meter, then plus I have 1 multiplied by 1, that is UDL, and it will act at its center, so its center will be at 0.5 centimeter, 0.5 meter from B, that means 2 plus 2 4, 4.5 meter from A. So 1 into 1 is 1, and it will act at a distance of 4.5 meter. So therefore this will give me the value of RB. So RB is equals to, using our calculator we will find out 3 times 2 is 6 plus 4 times 2 is 8 plus 2 times 4 is 8 plus 4.5, this total is 26.5, that divide by 5, that divide by 5, so this will be 5.3. So RB is what? It is 5.3 kilonewton. Okay, this is RB. So we get RB. Now RA I am writing directly. In the last problem you understand how to solve it. So RA will be total downward force minus 5.3. So total downward force is what? It is 3 times 2 6 plus 4 plus 2 plus 1. This is total downward 13. So 13 minus 5.3. So 13 minus 5.3, 13 minus 5.3 is 7.7. You all know how to calculate the support reactions. So this support reaction here is 7.7 kilonewton, and here it is 5.3 kilonewton. Now we will draw the S.F.D. So shear force diagram for this, I will draw this line AB. Then at A I have a value of 7.7. Here it is 7.7. Then it is going down its UDL. So 3 times 2 is 6. So by 6 unit we will go down. So we will go down like this. Okay, so 7.7 minus 6 is what? 1.7. So here the value is what? 1.7. Then here there is a sudden fall because this 4 kilonewton is going down. So 1.7 minus 4, 1.7 minus 4, that will give me 2.3. So this value here it is 2.3. Then I will go like this horizontal, and then there is a drop of 2. So 2.3. Okay, again minus 2 is what? 4.3. And then there is a drop of 1, but it will go like this inclined because it is UDL, and then we will close like this. Okay, so this is 5.3. Okay, now what shear force indicate? Shear force indicate the transverse force at any particular section. Okay, this is what the definition of shear force we can say. So this here this value is positive and this whole value is negative. So anything below your axis, your line, horizontal line, is negative, and the one which is above is positive. Now here this shear force crosses this line at point C only. So there is no need to find x as we have done in the last problem. Now we have to calculate the bending moment. So bending moment we have to calculate at point A and point B. Obviously the bending moment is 0. Okay, but here I will write one by one. Bending moment calculation. So moment at point A and moment at point B, it is going to be 0. Moment at point C, if we calculate, so we let us look on the left side. So it is 7.7 times 2 minus it is 3 times 2 times at what distance this UDL is acting at a 1 meter from point C, so times 1. Okay, sagging is positive, hogging is negative, so moment at point C we will get 7.7 times 2 minus 3 to the 6, so 9.4, so 9.4 kilonewton meter moment at C. And moment at D, so to calculate moment at D, let us see towards right. So if I see towards right, I will get 5.3 times 1 minus 1 time 1, that is total load, and it is acting at 0.5, so into 0.5. So 5.3 minus 0.5, I will get 5.3 minus 0.5, we will get 4.8 kilonewton meter. So we get all the values. So here we will draw a line, horizontal line, and for simply supported load, moment is sagging only. So MA MB is 0, MC is 9.4. So MC is 9.4. Let us see here. So it will go like this. This value is 9.4, and then at D it is 4.8. So 4.8 will be somewhere here. This value is what? 4.8. So from here it will go like this, and then from here we will join this. Okay. So here it is 0. Okay. Here it is 9.4. Here it is 0. This is point A, B. This point is your C, and here this point is your D. This is your bending moment diagram, positive sagging bending moment. Okay. Now let us move to the next question, third question. So here our third question. Okay. Again this third question is a overhang beam. Okay. Now here we will discuss a overhang beam. So AB, here I have a support, and then at 2 meter distance I have a load of 4 kilonewton. Then at 2 meter from here I have a support reaction. So this is A and this is AB. So RA and RB we will get, and then there is a overhang at 1 meter. So here at 1 meter, so we will reduce this length, and we'll say that at 1 meter there is a vertical load. Now this vertical load is 4 kilonewton. So here it is RA, here it is RB, this is 2 meter, this is 2 meter, and this is 1 meter. So here it is 2 meter, here it is 2 meter. Okay. So again I have to find out reaction at A and B first. So for that we can say that moment at point A is 0. So this imply that RB times 4 is equal to, now clockwise moments are 4 times 2 plus 4 times the total distance from point A is what, 5. So therefore we get the value of RB. 4 times 2 is 8 plus 4 times 5 20. So 28. RB is 28 divided by 4. 4 7s are 28. So value of RB we get 7. Now value of RB is equal to 7 kilonewton. Total downward reaction is 4 plus 4 8 7. We got RB. So RA, but obviously it is going to be 1 kilonewton. Okay. Now I have to draw the shear force diagram. Shear force diagram is quite simple. I will draw a straight line. Now here there is a reaction of 1. So this is 1. Then there is no load from A to say this point is C and this point is D. So at point C I will move straight, and then there is a load of 4, so I will go by 4 down. So 1 minus 4, here I will have a value 3. Then I will go straight, and then RB is 7. So this is minus 3. Now minus 3 plus 7, if I see, we will get 4. So we will go like this, and then this value is 4, and then from here we will join. Okay, so this is plus, this is minus, and this is plus. The value is 1 here, minus 3 over here, and plus 4 over here. This is your S.F.D. Now we will find bending moment. So bending moment at point A is 0. So moment at A, if you see, moment at A is 0. Moment at D is also 0. If I calculate moment at B, it is hogging moment 4 times 1. So I will say that minus 4 times 1 is equals to minus 4 kilonewton meter. And then moment at point C is equals to, moment at point C is what? 1 time 2. That's it. Because on the left of point C, there is only one load, which is reaction. So 1 time 2. So we get moment at A0. Here for bending moment, we will draw this line first. Moment at A0. Moment at B is moment at first we will see C. What is moment at C? It is 2. So here we will get a value 2. It will be joined by a straight line. Then moment at B, we will see moment at B is minus 4. So this is point A, this is point B, this is point C, and this is point D. So at point B, I have a negative moment of minus 4. So that point will be somewhere here. So we will join like this. Okay. Here this peak value is moment at C. This peak value is 2. Here this peak value is what? Minus 4. And then I will close this. Okay. So this is plus and this is minus. This is my bending moment diagram for this particular problem. Now we will see the fourth question. Fourth question is a cantilever. Here I have a cantilever with 2 kilonewton per meter. Here there is a UDL of 2 kilonewton per meter, and there is a point load of 2 kilonewton. Here I have a point load of 2 kilonewton, and then I have a point load here. There is somewhere a point load of 4 kilonewton. Okay, the total length here is 3 meter. The total length here is what? It's 3 meter. Now this is cantilever. Okay, a few things which we should know is that at what length this 4 kilonewton is acting. Okay, let me check if I get some answer for that. Hmm. 4 kilonewton is acting at 1 meter. It is acting at, so from here the distance is 1 meter. Okay. Now here while drawing the shear force diagram, there are two ways we can draw. Now you can see that this is cantilever. So at this point A, I have two reactions. One is vertical reaction and one is this moment. Okay. So I have two ways of solving this problem. One, either I will find this support reaction at A, or I will start from point say this point is B and here this point is C. Okay, so while drawing the shear force diagram, I can see towards left or I can see towards right. Now if I see the force on the right side of B, there is no force. But when I draw a section towards left and C on right, I will get a 2 kilonewton going down. So in shear force diagram we have seen that on the left if it is going up, or on the right if it is going down, it is a positive shear force. Okay, so here this 2 kilonewton 2 kilonewton is a downward direction shear force, so it is positive, so I will draw 2 kilonewton like this. This is 2. Then this is UDL. Okay, but I will calculate this UDL till point C. Now from B to C it is 2 meter length, and for 2 meter the total UDL is 2 times 2 is 4. So what I will do, in this 2 I will add 4. So at point C the value of shear force I will get is 2 plus 4, which is 6. Now all these are in kilonewton. All these are in kilonewton. Then at point A, the total shear force which we get. Now there is a 4 kilonewton. Okay, 4 kilonewton force. So that force, what we do, let us place here. Huh. Now that 4 kilonewton, if I draw a section towards right, this 4 kilonewton is going down. So I will add 4 kilonewton to this. Now 6 plus 4 is 10. And then for 1 meter there is again UDL of 2. So again it will go like this. And then here I will get 10 plus 2, 12. Now I will close this part here. Now see, if in the beginning I find out reaction at point A, I will get 12 kilonewton only. But for cantilever, okay, for cantilever, to draw the shear force diagram, it is better that we start from the right end. We start from the point B. So you can say that shear force towards right of B is 0, towards left of B is 2. Then shear force towards right of C is 6, towards left it is 10. Okay, and similarly shear force at point A is 12 kilonewton. This is shear force diagram. Similarly bending moment diagram we can draw. Okay, so for bending moment diagram, here we have bending moment. Now bending moment at point A is not going to be 0. Bending moment at point B is 0, that is free end. At point B it is 0. Then I will calculate bending moment at C. So here bending moment, I can say that moment at B is 0. Moment at C I have to find out. Now this is hogging bending moment, so it is we have 2 kilonewton point load, so 2 times, I will say that 2, because from B to C the distance is 2. It will be negative, minus I have 2 times 2, this is UDL total load, and it is acting at a distance of 1 from point C. So this is what I have written. So moment at C, and if I look on the right side, this is what we will get. So this is minus 4, it is minus 8. So minus 8 kilonewton meter is your moment, bending moment at C. And finally bending moment at A, if we see, so it is minus 2 times total length is 3, then it is minus 2 times, it is this UDL is also acting for a total length 3, and its effect will be at the center of this 3 meter, which is 1.5, and then minus this 4 kilonewton is acting at a distance of 1. So this is our bending moment at point A. Now we calculate this bending moment at point A. It is minus 6. So this is minus 6 minus 6 into 1.5, 6 into 1.5, and then minus, it is 4. So it is minus 19. So minus 19. Okay, minus 19 kilonewton meter. Okay, so what we observe, that bending moment, now bending moment here all the bending moments are negative, so this line, instead of drawing at the bottom, better we draw here, and at point C we get bending moment as minus 8. So it is something like this. Now as here it is UDL, so as it is UDL, so our bending moment will not be a straight line, but it will be a curve like this. It will be a curve like this. Now here at point C we get answer as -8. So here at point, say this is -8, so our curve will be something like this. And then at point A our value is -19, which is too much, so here there will be a steep curve. So this is point C, and at point C the bending value is what, -8 kilonewton meter, and at point A it is -19 kilonewton meter, and this whole is a negative bending moment. Okay, one more cantilever problem. Mm, the total length now for this cantilever, the total length is 4 and up to 2 meter. On the right side there is a UDL. This UDL is of 2 kilonewton per meter. This vertical point load is what, 5 kilonewton. This length is 2 meter from here. This length is 2 meter and total length is 4 meter. This is cantilever end. Okay, so again I will start drawing shear force diagram by looking towards right of the section. Okay, so this is point A, say this is point B, and this is point C. Now there is no point load at point B, so we will concentrate at point C. If I take a section just towards the right, and if I see towards right, so 2 times 2, that is -4. There is, okay, -4 kilonewton going down. So whatever is going down, that we take as plus. So 2 times 2, 4. So at point C we take a value like this, and as this is UDL, okay, as this is UDL, shear force diagram will be a straight line like this. Okay, this value is what, 2 times 2 is 4, so this is 4 kilonewton. Then 5, okay, if I take a section here and I see towards right, so 5 is going down, so that 5 I will add. So here 4 plus 5, it is 9 kilonewton. Then from C to A I have nothing, so I will go straight and then I will join like this. So this is point A, this is here point C, and here it is point B. Okay, if you wanted to draw your shear force diagram from end A, then you have to first calculate the reaction at point A, and calculation of reaction is same as we done in the last problem, that summation of Fy is 0. Okay, now the bending moment diagram, again the bending moment diagram. At point B the moment is 0, at point C the moment is 2 times 2, that is 4, and 4 is acting at a distance of 1, so 4 into 1 is 4. So here bending moment is -4, it will come like this, it is -4 kilonewton meter, and then at point A we will find, so moment at point A will be 2 times 2, this is for UDL, and it is acting at 1 meter from point C, means if I calculate from point A it will be 3 meter. This is negative moment, and then there will be a negative moment because of this point load of 5 kilonewton. So 5 kilonewton is acting at 2 meter, so it is 5 times 2. So here moment at A we get 2 to the 4, 4 3 the 12, -12 minus 5 to the 10, that is -22 kilonewton meter. So -22 kilonewton meter, here it will be somewhere here, and this part I will try to join by a straight line, okay, because there is no UDL, and its value is what, -22. This is -22 kilonewton meter. Okay, so S.F.D and B.M.D. And now last question. Again here I have what I will say in the last problem, just a minute. Hmm. It is overhang on both the sides. So I have overhang on both the side. Now the supports are here. One support is here. Other support is here. This is 1 meter on this side. 1 meter on this side. At the end here I have 2 kilonewton load. Here I have 1 kilonewton load, and in between I have 3 kilonewton per meter. In between I have, this is 3 kilonewton per meter, and the distance between them is also 3 meter. Okay, now I have to draw SFD. Now for SFD, here in this case I have to find out reaction. I will consider this as point A, this as point B, this as C, and this as D. Okay, it's our choice what name we give. Now if I take moment at point A, summation of moment at A is going to be 0. So therefore RB times 3, this is anti-clockwise moment. Now anti-clockwise moment, is there any other anti-clockwise moment? So about point A there is anti-clockwise moment because of this 1 kilonewton. So RB times 3 plus 1 time 1 is equals to, now clockwise moment what we have 2 times 4. Now this 2 kilonewton is acting at a distance of 4 meter from point A. So 2 times 4 plus UDL is what, 3 times 3, and it will act at its center. So that means at a distance of 1.5 meter from point A. So it's into 1.5, right? So therefore this will give me RB. So RB is 2 times 4 is 8 plus 3 times 1.5. Just a minute. What I have? 8 plus 3 times 3 times 1.5. So this total is 21.5. 21.5 divided by minus 1 divided by 3. Okay, this one will go on that side. So it is minus 1 divided by 3. So 6.83. Now RA plus RB, summation of Fy, na, we say that summation of Fy is 0. Therefore RA plus RB is equal to, total upward is equal to total downward. Downward is what, 1 plus 3 times 3 plus 2. So therefore we have RA is equals to 3 times 3 9, 9 plus 2 11 plus 1 12. It is 12 minus RB. The value of RB is what, 6.83. So 12 minus 6.83, it is 5.17. This is 5.17 kilonewton. Okay, so we have RA. The value of RA is 5.17 and the value of RB is 6.83. Okay, I will draw SFD first. So for shear force I will draw this line, and then if I see towards left and any force is going down, so it will be down. So there will be 1 unit here, then straight there is nothing. Then RA, the value of RA is 5.17, so I will go 5.17 up. So this will become 4.17 because here it is minus 1, then we go positive. Then we will go by 9 unit down. So from here if I get 9 unit down, so 5.17 minus 9, if I say, I have minus 3.83, that is minus 3.83, and then beyond this it will be a straight line, and No, not a straight line. Actually, what happened at this point B, there is a reaction of 6.83. So to this I will add 6.83. So I will get something like this, minus 3.83. So what we have, minus 3.83 plus 6.83. So we will get result as 3. Now there is definitely some mistake we have done, because finally we should get 0. So what mistake I have done? 3.83. This value is negative here, this value is negative, this value is positive. RB, it is 2 times 4 plus 3 times 3 times 1.5, and here 1 time 1, and RB times 3 and 1 time 1, so 4 to the 8. RB is 8 plus 9 into 1.5, 8 plus 9.15, then minus 1, then divide by 3. 6.83 is perfect. Now RA, we have total 3 3 the 9, 9 plus 3, 12, 12 minus 6.83. So 12 minus 6, 12 minus 6.83. The value is 5.17. RA is what? 5.17. Okay. So initially I have 1 kilometer down, then 5.17. When we go up, we get 4.17, and 4.17 minus, if we do 9, it is 4.83. Okay, so this is 4.83 minus 4.83. This value is what? Minus 4.83. So as it is minus 4.83, what happened? Stroke erasure. Okay. Hmm. I have minus 4.83, so it will go like this. It will be something like this, and then I will go here. Instead of 3, I have value 2, and then it will be 2. Close. This is minus 4.83. This is minus 1. This is my S.F.D. Now you see that this shear force diagram is cutting here. So this is the point where I will get the highest bending moment. So I have to calculate this distance. Let us consider this distance x. Now from here to here the total distance is 3. So the remaining distance will be 3 minus x, and we use the similarity criteria. So by applying similarity criteria, what we can say? We can say that this 4.17 divided by x will be equal to 4.83. Here it is 4.17, here it is 4.83 divided by 3 minus x. So we will cross multiply. 4.17 times 3 minus x is equals to 4.83 times x. Okay, so 4.17 into 3 minus 4.17x equal to 4.83x. So therefore 4.17 into 3 equal to 9x. So therefore the value of x is, it is 4.17 times 3 divided by 9. It is 1.39. So 1.39. At 1.39 meter from this point A, we have the maximum bending moment. Okay. Now bending moment at point C and D are 0, but it is not 0 at B. Okay. So if I calculate moment at B, it will be hogging moment 2 times 1. So it is minus 2 kilonewton meter. So minus 2 kilonewton meter, I will get a point like this, minus 2 kilonewton meter. Okay, then at point A, at point D it is 0, at point A it is again hogging at this end, so 1 into 1, here it is 1. So at point A I will get value 1, negative. Okay, so here it is minus 1, here it is minus 2. Okay, then at a distance this x, we say that we have maximum bending moment. Say this point is we have marked A, B, C, D. Let us mark this point as E. So moment at E, and if I see left, so there will be 1 into minus 1 into, now the value of x is 1.39. So 1.39 plus 1 is what, 2.39. Why I am taking 2.39? Because from E, the distance of this downward load is 2.39. So this is hogging, and then because of the reaction at A, the reaction at A is 5.17. Reaction at A is 5.17. Because of this 5.17, I have sagging, and the distance from this point A to this point E is what, x, which is 1.39. So 1.39, and then because of this UDL, I have hogging moment, which is 3 times it is 1.39 times 1.39 divided by 2. So I will say that 1.39 is square divided by 2. So moment at E, it is minus 2.39 plus 5.17 times 1.39, then minus 3 into 1.39 into 1.39 divided by 2 is equals to, it is 1.898. So 1.9 I will say. So this is 1.9 kilonewton meter. 1.9 kilometer positive. So at this point I have a positive moment. So this moment diagram will go like this. It will go like this. Okay. So this is negative, this is positive, this is negative. Now this peak value is 1.9 kilonewton meter. Okay, so this is your BMD, bending moment diagram. Okay, BMD, and here it is S.F.D, shear force diagram and bending moment diagram. So this is all about shear force diagram and bending moment diagrams. So we have studied different types of problems. Simply supported load we have seen, overhang beam we have seen, where overhang is on one side, overhang is on both the sides, and we have seen cantilever. Okay, in cantilever we have seen how to draw the SFD and BMD. Okay, I hope it's clear. Okay, I have not done in-depth calculation part. Okay, that you can do from your experience. You can do like by seeing your textbook, or reaction calculation you have already know, so there you can do. Okay, so thank you for being with me. If you have any query or doubt, you can surely comment me, and I will try to answer you. Thank you.